Hello everybody, thank you for joining us today. I'll just introduce my colleague Seamus Rooney in 1 second, but I'm Lindsay Teal and I'll be today's host for the webinar, which should last around 45 minutes. So we're joined today by Seamus Rooney, and Seamus is one of our renewable heat specialists and has worked with organisations across Scotland to help them design and install renewable heat solutions, so from heat pumps to solar, thermal, and of course today's topic, biomass. Now, if during the session you want to ask any questions, you'll see on screen there the questions panel. So at any point during today's session, just enter your question and it will come to me, and we'll stop at a couple of points throughout today's session to put those questions to Seamus. And if we've got any questions we don't get a chance to answer, then we'll do so, we'll follow up with you after today's webinar. If you use Twitter and you enjoy tweeting, then we also encourage you to use the ResWebinar hashtag so we can track all the tweets that are coming in. And if you want to tweet your questions rather than use the questions panel, then I'll pick those up as well. So that's it. I'll hand you over to Seamus, who will start today's webinar.
Hello everyone. Today we're going to talk through our top 10 10-step process to follow to carry out a successful biomass project. We're going to go through the steps themselves, and then afterwards we're going to go through some key problems to avoid, and once you're up and running with the biomass system, how you can run it so that it will be successful. So the 10 steps we're going to cover today, you can see on screen now. The first few steps are preparing yourself for discussions with suppliers, so that when you speak to suppliers you're informed and you've got the information that they need. It means that you can get the best out of your engagement with them. Then I'm going to talk you through step 4, once you're speaking to the suppliers and once you start to review quotations and you're speaking to a few people. And then finally, later on, steps 6 to 10 are once you've decided what you're wanting, you know exactly how you're going to go about getting it. It's following through the process to make sure that what you get is what you want. So we're going to start off now with a poll, and I'll hand you over to Lindsay.
Yeah, so we just really want to understand, as we're starting, what kind of stage everybody joining us today is at. So I'll just launch the poll and it should be coming on screen now. So really, what stage in your biomass journey are you at? Are you just investigating the options? Are you now at the development of a specification? Are you already looking for suppliers, or are you looking to run an existing system better? And so if you could just start completing that poll on now, then it'll give us a kind of steer on what stage everybody's at. So a bit of a mix at the moment. Most people online are just investigating, with a few developing a specification and a few looking for suppliers, but nobody is looking to run an existing system better, so most people are obviously at that kind of initial biomass stage.
It's quite interesting.
Yeah.
Hopefully today's webinar will be helpful to steer you in the right direction.
Yeah, I think it'll be perfect for you to kind of get going. So I'll just share the results with you on screen. So it's 83% are just investigating, 8% developing a specification, and 8% looking for suppliers. So that's it. I'll hand you back over to Seamus.
Thank you very much. So our first step in the process is really key. It's understand what your requirements are. So that biomass systems are providing heat, and so key to that is understanding about your heating requirements. How much heat do you use, how do you use the heat, and how is the heat distributed? So the first part of that is how much heat you use. And what you want to find out is a sense of how much heat you use over a year. Now, that'll be in kilowatt hours. Ideally, if you've got heat meters, it can be measured directly, but they are pretty rare. Most people won't be in the situation of being able to meter their heat and know exactly what their consumption is. So in that case, you can find out how much fuel you use, either from your existing bills or from delivery notes from suppliers. So electricity and natural gas will state how much energy in kilowatt hours you have consumed, and that's excellent. You can gather that information, ideally for a full year, because if you've got one full year's information, then it takes out any seasonal variations you've got, and it means that they can get as accurate a picture as possible. The longer you've got data for, the better informed your supplier will be, and the more likely it is you get the system you need. If it's not electricity or natural gas, so if you're using LPG or if you're using oil, it's most likely the volume of fuel you've used. So you'll have to convert that into kilowatt hours, either yourselves or if you're doing some of the calculations yourselves, or if it's your suppliers doing that, they'll do it for you. The DEFRA website has information on it about the energy content of different fuels, and so that's the best source of information. Now, when you're measuring fuel, that's the energy going into the boiler. It's not actually how much is coming out as heat, because the boiler will be somewhere between 50% and 80% efficient over a whole season. It may well be more than that, and boiler manufacturers can state in excess of 90% efficiency. But over a whole, what you're wanting to, what's important here is over a whole heating season, so during times where there's relatively little load through to times when, in the depths of winter, when the boiler's working very hard, how's the efficiency average out? And so it does mean if you've got a very old boiler, your heat demand might be quite a lot lower than it appears from the fuel consumption. And it's something that it's not investigations you need to make yourself. Those kind of things, working out the efficiency would be done by the installer. But having a sense, first of all, having all the information ready for them, so the energy consumption, your bills, and having a sense yourself of what your energy consumption is very useful. The other reason it's important is because it will impact on how much renewable heat incentive you get, and it will be used in your own internal calculations of the business case. So it's really important that that is known, and is known as accurately as possible, the total heat consumption for the year. So moving on to peak heat loss. This is the maximum rate you use heat, and this is what's used to decide how big a boiler you need. And the peak heat loss will be different for the different heat consuming systems you've got on site. So if you've got space heating, if you use hot water, or if you use process heating, then each of those will have their own peak requirement. And the peak requirement of the whole system will be those systems which operate at the same time. So it might be, for example, if you've got process heating which is running 24 hours a day, and you've got space heating only on during the day, and you hot water on at night, it won't necessarily be all of those added together. What's key here is understanding what information your supplier is likely to need from you so that they can work it out. It's not something that you're likely to have to work out yourselves unless you're getting deeply involved in the sizing of the system. So for space heating, for example, we need to think of how big a building is it, what age of construction. We want to know as much information as possible about the fabric of the building so that they can calculate accurately what the requirements are. For hot water, it's how much hot water you use, and also its pattern of usage. So if your business is a cafe, for example, does it you use it only for hand washing, or do your dishwashing equipment use hot water, or is it electrically heated? So if you can gather as much information on these as possible, then again minimises the amount of estimation your supplier will have to do, and will help you get a more accurate idea of the correct system from the start, and will hopefully assist you in getting the right system when you finally go to purchase it. I'd reiterate, it's the responsibility of the installer to size the system for you. But if you inform them correctly, then it helps them do their job. So moving on to boiler sizing, it's important to note here that it's not always the case that a biomass boiler would be sized to meet the peak load. It's important that your heating system overall, so the biomass boiler and any other heat sources, are able to fully provide for your needs. But if a biomass boiler is oversized, it tends to be inefficient. And this is a result of biomass boilers reacting relatively slowly to load, and also they are limited in the extent to which they can ramp up and down their output. And so sizing of biomass boilers needs some care, and usually it's done in combination with some buffer tanks with thermal stores to spread out the load. Or it can be that one or more biomass boilers are used together, or indeed another heat source, so perhaps an existing oil or gas boiler as a backup with a relatively small biomass boiler for base load. Now, as a consumer, this is important because if you're looking at different installers and you're getting very different numbers back in terms of the boiler requirement, having an understanding of the way that biomass boilers can be used to best efficiency and to make sure they're reliable will help you make sure that you can pick which supplier is the one that's most likely to give you the system that's going to work well for you. And so we're going to move on now to another poll, so I'll hand you over to Lindsay.
Yeah, so we're interested to know currently what heat source you use. So coming on screen now, you'll see the options that we've got there are natural gas, LPG or oil, electricity or other. So if you could just take a couple of moments to complete that, that'll help give Seamus a steer on kind of where people are at right now. So natural gas is kind of in the lead at the moment at 71%.
That's quite interesting, and there's also quite a number of people using electricity as their main heat source.
Mm-hmm. So I'll close that now. I think most people have taken the time to complete that, and I'll share the results with you. So 73% natural gas, 9% LPG or oil, 18% electricity, and 0% using any other heat source.
What's interesting about that is that the different fuels that people use has a real impact on the financial, the payback of a system and how much you can save. And the 18% of people who are on electricity are most likely to be able to make very significant savings. With natural gas systems, that can be a bit more of a challenge to make the systems pay, and it's really important to get the sizing of the system right and make sure the calculations are, your business case is robust, to make sure that you really accurately understand what the savings are going to be.
Fantastic. So I'll take those down and I'll hand the slides back over to Seamus.
So the next thing, just continuing on with information about your system. It's really important that you understand how the heat's distributed. So the existing system that the biomass boiler is going to connect to. Most systems are low temperature hot water. So this is water up to around 100 degrees. And if no information is available, it's very likely that the installer will make the assumption that that's the system you've got. So it's really important that if you use medium temperature or high temperature hot water, which operate at much higher pressures, or if you use steam, that you make that very clear from the outset, because the equipment you need is likely to be different. And businesses which process heat, for example, quite often uses steam or high temperature hot water, or even other mediums such as oil. If you're operating in a factory, they tend to be very different from what the types of systems that would be doing space heating and domestic hot water in a building. So moving on, getting away from the technological requirements, it's really important you understand what your own financial requirements are as well. What is it you're trying to get out of it? How much money do you have to spend? What's your access to capital? And what return do your business require? Is it the case, for example, that a system which is going to be more capital intensive but offers a better financial return something that you would consider? Or is it really important? Is the cost of the system initially the most important? Understanding those things will help steer you towards the right system. There's a lot of different types of biomass systems out there and they perform very differently. So once you understand what you've got and what your financial requirements are, the next step is to try and find out what's actually technically possible on your site. And so when your installer is making an assessment of this, it's going to be specific to the types of fuels that they're considering. Many suppliers will do more than one type of biomass boilers, but some specialise. So it's important that you have an understanding of the different types of biomass and which of them might be suitable for you. So just quickly, wood pellets are the most manufactured of the wood fuels. By that I mean they're a regular size. They are pellets of usually between 6 and 8 millimetres. They are dried to a preset moisture content. They're produced in a factory, and because of that, they are easy to handle through automated equipment. They can be delivered automatically into fuel stores, and they tend to result in systems which operate efficiently and reliably without a significant amount of intervention. Biomass boilers will always need some more intervention for cleaning out ash removal and that kind of thing compared to oil and gas, but of the fuels, the wood pellets are the least work day to day. But the downside of that is the fuel is more expensive. So wood chip is quite often attractive for people who use a significant amount of heat because the cost of the fuel is less. The downside of wood chip is that the cost of the equipment that you require is likely to be much more. Fuel handling is not as easy. The mechanism, part of that is because the wood pellets will fall naturally to the bottom of a wood store, whereas wood chip won't. It sounds like a bit of a technical point, but it really fundamentally affects how the mechanisms that you need. Wood chip can form bridges and can form caverns, and so it needs a lot more equipment to move it around, and that's a lot of money. It also takes up more space. So wood chip systems can be an excellent option for sites which use a lot of heat, and it's worth them investing more money at the outset to save money on the operating costs later on. The other issue potentially with wood chip is that the moisture content tends to be a lot higher, and you tend to encounter more operating problems than you would do with wood pellets. It's less uniform, both in terms of the size of the pellets and in terms of the moisture content, and both they can affect either the boiler itself or the fuel delivery system. Either way, it could have an impact on your business if it turns off. Log boilers are very different from wood chip and pellet boilers on the whole. They tend to be manual systems. They're manually fed. They require intervention usually once or twice per day, where pellet or chip systems may operate for a week or more without anyone having to go to the boiler. And they are most suited to the likes of agricultural sites where there are people who are able to clean out the boiler, feed the boiler manually. And so they don't tend to be suited to the likes of office environments. So when making an assessment of the suitability of your site, one of the most important things is whether you've got space for the plant. Biomass boilers, buffer tanks, biomass fuel stores all take up significantly more space than oil or gas systems. And so having somewhere to store fuel, having somewhere to locate the equipment is going to be very key, but it's also important you can get things onto site. So access, whether that's the width of access roads, whether that is the access directly to the fuel store. So it's important that a fuel delivery lorry can get up to where you're going to be storing the fuel. Also, it's worth considering from your business perspective what the impact, how much labor, how much time it would be possible to spend operating the boiler. So for a system which needs more manual intervention but it's much lower running costs or much lower capital costs, for example, is that something you would think of, or can that be ruled out at an early stage? Does it need to be something that operates automatically? Understand, it's important you make those decisions yourself so that you can communicate them to the supplier. It also might impact on whether you decide to use a maintenance contractor to do some of the work for you. The limitations, one of the limitations potentially on where you can locate biomass boilers is air quality management areas. These can be found on your local council website, and these will place a restriction on the design of the system, and really they can prevent biomass systems going ahead because it can become unaffordable to install the flue gas treatment that's required to comply with the air quality management area restrictions. The planning restrictions affect some sites more than others. And so it's worth thinking about. This can also be for listed buildings, for example. So if you are in a situation where you're likely to need a very tall flue, and you are placing it somewhere that has very restrictive planning environment, it's worth being aware of that, considering it, and having conversations with your planning department at an early stage, because it's important both to make sure that you, if it's possible to go ahead with a system, that you're aware of what you're going to have to consider, whether that's aesthetically or design of systems, to make sure you comply with that. But also, if there's something which is going to clearly prevent you going ahead, it's not worth investing a lot of time in getting to a much later stage only to discover that something you could have known at the beginning which prevents it going ahead. And finally, it's just a little point specifically, if you've got a site with changes in level, it's worth identifying that with your supplier, because one of the major costs with wood chip is the delivery, the mechanisms to receive a delivery of wood chip, and they can be tipped from a tipper lorry. If you happen to be lucky enough to have a site where you've got an access road and somewhere you can place a plant room adjacent at a lower level, they're ideal for wood chip. So moving on, step 3. It's important that you can source fuel which is affordable and which is of a sufficiently reliable quality that you're going to be able to operate the system for its lifetime. And so for the type of system that you're considering, if you have made a decision early on, or if you're still very open-minded about what you want, it's worth finding out what fuel is available in your area. So fuel suppliers, for pellets, they may be more national suppliers, and it might be an issue of what's the cost of getting it delivered to your site if you're in a very remote location. But finding out all of the suppliers, what fuels they can supply, again, what delivery vehicles they need to use. If they have a articulated lorry, certain suppliers only do very large deliveries using very large delivery vehicles. Are they going to be able to get to your site? And if you have you find that you're restricted to a small number of suppliers and an individual supplier, it's worth considering whether they're going to be around for, say, 20 years that you're operating the system for, or if you're going to be exposed to significant fluctuations in fuel price, which might affect your business case. Finally, as I mentioned before, some suppliers only do large deliveries, but many of them will offer you a discount for large volumes. So if you're doing 10 tonnes or more, then some pellet suppliers will give you a discount. It's worth being aware of that at an early stage, because it may be that installing a slightly larger fuel store doesn't add a lot of cost if you've got the space to do it, but could save you quite a bit of money for operating the system later on. So, we're going to, Lindsay, we're going to look at some questions now. Have we got some come in?
Yeah, we've got a couple of questions that have come in, but yeah, if you've got any that you want to ask, then just pop them in the question box that you'll see on, it should be on the right hand side of your screen if you've got any questions. So the first question we've got is, someone's asking, can I start out burning wood pellets and then swap to burning wood chip at a later date?
It's a good question. Now, it can be possible, but the fuel handling equipment is different for wood chip boilers than it is for pellet boilers. And so if you have a system which burns wood chip, it's more likely that it's able to burn pellets. If you buy a system which is designed for pellets, you are more than likely not going to be able to burn wood chip. So it's something you need to decide when specifying the system. So if you get the right equipment from the outset, then it gives you that option later on, but it's likely to add some cost to the system. It's worth thinking about, again, if looking at fuel suppliers, if you know that there are wood chip suppliers locally and you can get wood chip affordably, there's quite a lot of people who will start off on wood pellets until they've got the system up and running reliably and get past any teething problems, and then swap into wood chip. But you need to think about it early.
Right, okay, perfect. The next question we've got is that somebody has access to their own wood supply, but they're wondering whether or not they can still claim the RHI, the Renewable Heat Incentive, if they burn this.
Yes, you can supply your own fuel. There's some restrictions in terms of if you're processing fuel, for example, but if you're sourcing fuel, it tends to have an impact on what type of system you'll look at, but it's certainly you're eligible to claim the RHI. It's worth looking into the fuel supply, the sustainability requirements which are coming into effect in autumn this year, autumn 2015. As a self-supplier, you'll have some requirements placed upon you for record keeping and that type of thing. But also, if you're self-supplying fuel, it's worth thinking about what type of fuel you're going to be. So if you get wood logs, for example, are you thinking about a log boiler, or are you going to get someone to chip it for you and have a wood chip boiler? It's worth having a bit of thought of the storage and handling implications of supplying your own fuel, because if you're looking at wood pellet or wood chip, it might be, certainly with wood pellets, you're not going to be able to convert the wood into wood pellets. It may be that you can get it chipped and dried, but it needs a bit more thought. But certainly log boilers, it tends to be much easier.
Okay. Hopefully we've got time for another 2 questions. The next one is, what is the typical asset life of a system?
Well, a reference point for this is that the RHI is payable for 20 years. And so if you're installing a system with the objective of claiming RHI, then you're looking for a system that's going to last for 20 years. Now, there are, in that time, you're going to have to do obviously a significant amount of maintenance, but also some plant replacement as well. And so the fuel delivery augers, the pumps, those type of things are likely to need replaced. But you would want the biomass boiler itself to need to be able to last for at least 20 years. It comes down to maintenance as well. If you've got a system which is fueled with good quality fuel, and by that I mean moisture content primarily, which matches the manufacturer's requirements, and it's regularly cleaned and maintained, then you're likely to get a very good lifespan out of it. If the system is not properly cleaned and isn't maintained frequently, then the life can be significantly reduced. One of the things we're going to talk about a bit later on is there are some implications of running a boiler at very small load, and that can significantly reduce the life of the boiler itself. And I think there's some points we can possibly pick up on after the webinar. But if you run a boiler at very low load, it is likely to reduce its lifespan, because you can cause corrosion inside the boiler if it's not coming fully up to temperature and operating at temperature. So it really does come down to how you operate the boiler. The best of boiler systems will fail after a relatively short space of time if they're badly maintained and aren't operated correctly.
It's actually a question from me, but building on Rachel's question, is there somewhere you can go to see the ratings for boilers, or how the quality of them?
It's a good question. There's not, as far as I'm aware, the quality rating. The manufacturers will have, for smaller systems below 45 kilowatts, they have to be part of the microgeneration certification scheme, and there's some checks they have to go through as part of that process. And so the installers which have become certified are on that. There's also the energy technology list where you can look for suppliers, but they tend to be about the performance of the boilers rather than their quality and longevity. Although biomass boilers have been running in this country obviously for a long time, but the uptake has increased significantly since the start of the RHI in 2009. So there's some experience out there. You can look to other people, but Austria, Switzerland, Germany have had high uptake of biomass for much longer than us, and so there is case studies and examples online. You can find out what suppliers get good feedback, and it's worth speaking to other people to find out their experience of biomass boilers.
Yeah, I was thinking the Green Network for Business might be a good resource for that as well.
Absolutely, absolutely.
So I think we'll stop with the questions tonight, and we'll ask a few more towards the end. So do just pop them in the questions box if you've got anything else you want to ask Seamus. So we'll move on from questions just now. Okay,
so we're going to move on to step 4, which is your initial discussions with suppliers. So by now you get some sense of what you're looking for financially out of a system, and you have hopefully an idea of how much heat you use, and some information about your existing system. Your